Hey guys, this is Mr. Grice for Algebra Unit 10.1 Notes, Day 2. Today we're talking about line of best fit. Our learning target today is to be able to write the equation for the line of best fit for a set of data and apply the equation for the line of best fit to answer questions regarding the data set. Woo, that's a mouthful. All right, well before we get started, let's first talk about one of the homework questions from last night. So one of the questions talked about test scores versus hours of sleep, okay? And so the hours of sleep were on the bottom, and they said that the test scores were your Y, so that would go on the side. And then, excuse me, but then we had, I'm sorry, I'm doing these really fast. So we had a bunch of points. This is probably a lot more points than what was actually going on, but they concluded that the more hours of sleep you get, the higher your test score was. But what we're going to be talking about today is just to get a general overview of what the line looks like. We're going to learn how to draw a line that goes through the data points. And what happens is you'll get about half of them above and half of them below. And this is called the line of best fit. Okay? Now that might not be the best fit line just because I drew it super fast. Okay? But overall, when this happens, you'll get half of the points will be above, half will be below, and then the line will go through some of them in most cases. And that's what we're going to be talking about today. So before we get started with that, we need to review a little bit, okay? When we're calculating slope, it's y2 minus y1 over x2 minus x1. So what we need is we need to have an x1 and a y1 and a x2, and a y2. So we need to have 2 points to be able to calculate slope. Okay? Now, another thing we need, when we're graphing, we need it to be in slope-intercept form. That means that y equals mx, and once again is our slope, plus b. Okay? And we would use this, so we would use if we're given the slope, and remember the slope is m, and if we're given the y-intercept, and the y-intercept is b, okay? So if they give us the y-intercept and they give us the slope, that's when we can use slope-intercept, okay? Now, excuse me, for point slope, we're going to use point slope if we're going to use this if we're given the slope, once again, which is m, and a point. Okay, so if they tell us the slope, and if we're given a point, and that point would be the y1 minus x1, or the x1, sorry, y1. Okay. Most of the points, most of the time is what's going to happen is they're going to give us 2 points. From these 2 points, we go into point slope, and then from point slope, we solve it, and we get y equals mx plus b. So most of the time, it's a 3-step kind of deal that we do. Okay? So let's look at the first question. The directions say to write the slope-intercept equation of the line described. Okay? So example 1, the line that passes through the points 4, 1 and 10, negative 2. So they gave us 2 points. So when they give us 2 points, step 1, oh, hold on a second. Sorry guys for the technical difficulties, my pen was breaking. Anyway, step 1 is we have to find the slope. So if we're finding the slope, we have to use the slope formula. And when I'm starting the slope formula, if you remember, we put the subtraction signs down right away so you don't get confused. Okay? So it's y2 minus y1, which means my y's go on top. So negative 2 minus 1. And then our x's are going to go on the bottom. 10 minus 4. Excuse me. So let's simplify. At the top, negative 2 minus 1 is negative 3. 10 minus 4 is 6. And when we simplify that, we get our slope is negative 1/2. So perfect. We got our slope, but I want the line. Okay? So with that, we move into step 2. Okay? In step 2, we have a slope and we've got a point. So we're going to plug into point slope. So y minus equals the slope, x minus. So we have a slope, and then we need to put our y point, okay? And remember, it doesn't matter which point you use. So the slope has to go there. And then we can either use the 4, 1 or the 10, negative 2. You're going to get the same answer. I try to pick the one with the less amount of negatives and the smaller numbers, okay? So our x is the 4 and the y is the 1. So we have to put everything where it goes, okay? And now we solve. So the first thing that we would have to do is to distribute. So we have y minus 1 equals negative 1/2 times x is negative 1/2 x. A negative times a negative is a positive, and half of 4 is 2. Okay, we're not done yet because the y is not by itself, so we have to add 1 to both sides. And then our final equation is we get y equals negative 1/2 x plus 3. Do you guys kind of remember how to do this? Okay, let's look at the next one. So the line that passes through the points 3, negative 9, and 6, negative 5. Okay, so once again, we have to do step 1 first, which is to find the slope. Okay, so our x's go on top, the negative 5 minus 9, and guys, I don't like seeing the double negative like that, so we're just gonna do click, click right away. And then on the bottom, we're gonna have 6 minus 3. Okay, so the top, negative 5 plus 9 gives us 4. And then 6 minus 3 is 3. Can I simplify that at all? No. So, perfect. We found our slope. And now we're going to do step 2, which is plugging into point slope. Once again, it doesn't matter which point you use, okay? You pick the one with the less amount of negatives, which I think these ones have the same amount, so maybe you just want to do the smaller numbers, okay? I'm going to use this point. So my slope, 4/3 goes right there. My y is a negative 9. And just like before, I don't like seeing the double negative, so I'm going to turn this into a positive right away. And then my x comes in the back. Our first step is to distribute the 4/3. So we have y plus 9 equals 4/3 x. And then 4/3 times 3, well, 4 times 3 is 12. 12 divided by 3 is 4. All right, are we done? No, we got to get the y by itself. So subtract the 9 to both sides, and we get that y equals 4/3 x minus 13. So there's your review. Just know that we're going to be using some real world problems once we flip over, and real world problems aren't going to have pretty little fractions. Okay? So before we flip to the other side, let's go through our definition of line of best fit. So what is the line of best fit? A line of best fit is a line that best represents the direction of a set of data points. Man, it's like magic. How did I get that to come up so fast? All right, anyways, like we talked about before, generally half of the points are above the line of best fit and half of the points are below. So if we're looking at our example, here we got 1, 2, 3, 4, 5. Looks like 6 above and 1, 2, 3, 4, 5. 5 below. And yeah, that's pretty good. And it went through 2 of them. That's going to be pretty typical. Okay. You can do the same thing if you want to count on the other side. So I'm actually going to stop the video right here. And then video number 2 is going to go through calculating the line of best fit. Okay. So if you have any questions, you know where to find us. But this is Mr. Grice signing off for Algebra Unit 10.1 Notes, Day 2, Video 1. Thanks for watching.